Hi there. In our previous lessons, we looked at adding and multiplying fractions and mixed numbers. Today, we're going to extend that and look at dividing. If I were going to look at these two problems, if I looked at multiplying 100 times 1/2, we know that the result would be 50 because 1/2 of a group of 100 would be 50. Likewise, if I did 100 divided by 2, I'm changing the operation from multiplying to dividing, I would also get the same result of 50. So here we can start to see there's a relationship between multiplying by 1/2 and dividing by 2. So if we just take a look at these two numbers here, 1/2 and 2, and we can look at we ask ourselves, what's the relationship here? Well, 1/2 and 2, another way to express 2 is 2 over 1. So now we can see that these have a relationship where they are flipped upside down. Numbers where we've flipped them over from each other we call reciprocals. Reciprocals are numbers when multiplied times each other equal 1. If we were to multiply this, we would see that 1 times 2 is 2, and 2 times 1 is 2, which would result in 1 overall. So any number where we multiply them times each other and we end up with 1 is going to be a reciprocal of the other. So some more examples of reciprocals would be 1/3 and 3, 4/5 and 5/4. If we add something like 1 1/3, we would turn it into an improper fraction, so 4/3 and 3/4. These are all reciprocals of each other. So looking at these reciprocal relationships, we can also make an assumption or conclusion about dividing by fractions. So here we multiplied by a fraction and divided by its reciprocal. So basically we flipped these over and we got the same result. So if I were to ask you instead 100 divided by 1/2, we could make the assumption, or we could make the conclusion, that that's the same as saying 100 times the reciprocal of 2 over 1. This makes dividing a lot easier. It's a shortcut. We can, instead of dividing by a fraction, we can change the sign from division to multiplication and then multiply by the reciprocal. Since we already know how to multiply easily, this would be 100 times 2 is 200 over 1, so that would equal 200. This makes sense because what this question is asking is how many groups of 1/2 can we get out of 100? Well, we could get 100 groups of 1, and if we took those groups, made them smaller, and did groups of 1/2, we would get twice as many groups. So we would end up with 200. This is the quickest way and the traditional algorithm way for dividing fractions. But this, the reciprocal relationship, is why it works. Next, I'm going to show you how we could use an area model to show it visually. Now I'm going to show you how dividing by fractions works with a visual model. So here I've got 3/4 divided by 1/5. So what I'm going to start by doing is making a box that I can divide into my 3/4. So here's my rectangle. Then I'm going to divide it into fourths because that's my denominator here. I know it's divided into 4 parts. I started with 3/4, so that's what I need to start with. So I'm going to divide it into 4 equal parts by making my 3 lines. And now I've got 1, 2, 3, 4 equal parts. Next, I want to fill in 3 of those because that's what I'm starting with. So I'm going to get a color here to fill those in with, and I've got 1 out of 4 here, 2 out of 4, or 1/2, and now 3/4, or 3 out of 4. There's 1 row, 2 rows, 3 rows, 4 rows, 3 rows out of a total of 4. So this part here is my 3/4. Next, what I'm asking is 3/4 divided by 1/5 is asking how many 1/5 can we get out of 3/4, or how many groups of 1/5 can we get in 3/4. So I'm going to use an array model, and I'm going to divide my box into fifths going the other way by drawing 4 lines vertically. Now I know that one of these columns is equal to 1/5. So I want to know how many of these columns could I make out of what I have here. Well, one of my columns would be 1, 2, 3, 4 boxes filled. So now what I'm doing is I'm looking in this filled in 3/4 for how many groups of 4 can I make. That's going to answer my question. 3/4 divided by 1/5, or 3/4. How many groups of 1/5 can I make out of 3/4? Here we go. So let's find out how many four boxes can I make out of 3/4. So here's 1. I'm looking for groups of 4. So there's 1. Here's another group of 4. That's 2. Here's another group of 4. That's 3. So I know that I've got at least 3, but there's some left over, because here there's 1, 2, 3 boxes left over. So how do I handle that? I know it's 3 and a little bit. I don't have 4 more to make a 4th set of 1/5, so I need to turn into a fraction. Well, I've got 3 parts, so that's going to be my numerator. So 3 is my numerator. Now what's my denominator? Well, how many make up a whole? Well, remember, we're not talking about this whole. We're talking about a group of 4, or a group of 1/5, which is 4 boxes to make a whole. So a group of 1/5, the whole is made up of 4 boxes. So 3/4. So 3 and 3/4 is my answer. Now, let's check it using our traditional algorithm model. We just looked before, on the previous slide, we talked about how to do this the shortcut way. So how reciprocals work. So we use 3/4 divided by 1/5, but we want to make that easier. So what I'm going to do is I'm going to change my division to multiplication, and I'm going to use a reciprocal for 1/5, which is 5/1. Just flip it over. Now I'm going to multiply straight across. So 3 times 5 is 15, and 4 times 1 is 4. Now I know that this is an improper fraction, so I'm going to reduce that into a mixed number. So how many 4s can I get from 15? Well, I know I can get 3 of them. That will make 12, and there's some left over. I can't get 4 wholes. That would be 16. I don't have enough in my numerator. So I know that it is 3, and that used up 12 of my numerator, 12 of my parts, and I've got 3 left over, because 15 minus 12 is 3. So I've got 3, and my denominator stays the same at 3/4. So here I've got 3 3/4 found using the model, and 3 3/4 found using the traditional math method. Alright, here we're going to do a visual model one more time, but this time we're going to have a mixed number here divided by a fraction. So what we're asking here is, I have 1 1/2, and I want to know how many 2/3, or how many groups of 2/3 can I get out of that 1 1/2. So I'm going to start by building my model of 1 1/2. Okay, so I've started with my model of 1 1/2. So here's a whole box, and here's 1/2 of the box. Now I want to use my 2/3 to divide it the other way. So I'm going to make an array the other way, divide my box into thirds the other direction, and I want to find out how many of those I can make. So here's my thirds, and my other box the same. And now what I want to know is, how many 2/3, or groups of 2/3, can I get out of this whole thing of 1 1/2? Well, first we need to know how many boxes are in 2/3. So there's 1, 2, 3, 4 boxes in 2/3. I'll show you that again. 1, 2, 3, 4 boxes make up 2/3. What I want to know is, how many of those 2/3 can I get out of what I have here? So how many sets of 4 can I get out of what's colored in? Well, let's just start finding those and counting them up. So here's 1, 2, 3, 4. There's one set. Here's 1, 2, 3, 4. There's 2 sets, and I've got this one up here left over. So I've got 2 and some other part. I've got 1 out of how many? Well, how many made up a full set? 1, 2, 3, 4. So my denominator is 4. So 2 1/4 sets of 2/3 can be made from a total of 1 1/2. Let's do the old algorithm way, just the straight numbers, and check our work. So we start with our 1 1/2 divided by 2/3. Well, before we do any operations with a mixed number, with this mixed number, I like to change it into an improper fraction. So 1 1/2 is the same as 3/2. Next, we're going to change this division sign. We're going to change our operation into multiplication. Then we're going to change our fraction at the end. We're going to use the reciprocal of it, because when we change this, we have to flip that, use the reciprocal. So that is 3/2 as well. When we multiply that straight across, 3 times 3 is 9, 2 times 2 is 4. And we can get 2 groups of 4 out of 9, so that is 2 wholes. And there'll be 1 left over because 2 times 4 is 8, so there's 1 left over to make our numerator of 9. So that will give us 1 left over out of a set of 4. So again, we've got 2 and 1/4 here using our reciprocal multiplication model, and 2 and 1/4 here using our visual model on the array. Hope this helps you understand how division of fractions and mixed numbers works. Good luck.